Hello everyone, Mr. Geiselhart here, and we're going to take a look at some matrix operations. So what are some matrix operations that we're going to be doing? We're going to be doing something called scalar multiplication, matrix addition, matrix subtraction, and matrix multiplication. One of the first things we need to do whenever we're looking at any kind of a matrix problem is that we want to know what the dimensions are of the matrix are. Now, we want to know what they are to start with, or the parts in the question, and then that will help us determine what the size of the matrix should be in the solution. So the first thing I'm going to do is just a couple of examples of writing down what the dimensions are of each of these matrices. When we do that, we do the number of rows by the number of columns. So in my first example here, we have 3 rows by 2 columns. So we say that's a 3 by 2 matrix. In the second one, we have 2 rows by 3 columns. So that would be a 2 by 3 matrix. This, we have 4 rows and 2 columns. So 4 by 2. In this one, we have 5 rows and 1 column, so that would be a 5 by 1 matrix. Okay, now we're going to look at adding and subtracting matrices. In order to add or subtract a matrix, the dimensions need to be exactly the same. So in my first question here, we have a matrix that's 3 by 2, and in the second one it's 3 by 2, so that means I can add these. In order to add matrices, all you do is you add the elements that are in the same position. So this one's in the first row, first column. This is in the first row and first column, so I add those two together. So 2 plus 0 is just 2. This is in the first row, second column, so I add those together. So -1 and -3 gives me -4. And I'm just going to continue to do that. So -1 and -4 is -5. 5 and 0 is 5. And then we have 3 and 5 is 8. And we have 4 and -2 is going to be 2. So my final answer of the matrix is going to be 3 by 2. So it's the same size as what we started off with. And then you just add each of the elements in those spots. Now, to subtract matrices, you're basically going to do the same thing. In this case, I have a 2 by 4 and a 2 by 4, so those matrices are the same size, so I can add them. Now, to make this a little bit easier, I'm going to go back to something we used to talk about a lot in math when you're doing subtracting. Subtracting is just adding the opposite. So I'm going to add the opposite, and I'm going to change all of the signs in here to make it a little bit easier. Now, since 0 isn't positive or negative, there is no opposite, so that will just stay 0. But this -4 will become a positive 4, -5 a positive 5, positive 2 becomes negative, 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 and positive. So now I can just add like we did before. So we'll have -1 and 0 is -1, 1 and positive 4 is a positive 5, 0 and 5 is 5, -5, -2 is -7, 2 and 0 is 2, -1, -5 is -6, 3, -4 is -1, -1 and a positive 2 is a positive 1. So again, notice that my matrix is still the same size. It is a 2 by 4 matrix. Okay, now we're going to take a look at some scalar multiplication along with addition. So what scalar multiplication means is you just multiply each element in the matrix by some number. In the first case, I'm going to just multiply each one of those by a -3. So my new matrix, in other words, -3 times A, will look something like this. -3 times -4 is 12. -3 times 2 is -6, -3 times 2, -6, -3 times 4 is going to be a -12, -3 times 1 is -3, and -3 times 3 is a -9. So I multiplied each one of the elements in this matrix by -3. Now I'm going to do the same thing, except I'm going to multiply everything in this one by a positive 4. So this matrix will be -8, -20, -16, 8, 8, and -8. So since I'm adding these two matrices together, notice they're both 3 by 2 matrices, so I can add them, and my answer will also be a 3 by 2 matrix. So all I need to do is add the individual numbers together. So 12 and -8 is going to be 4, -6 and -20 is -26, Negative 6 and negative 16 is negative 22. Negative 12 and a positive 8 is negative 4. Negative 3 and a positive 8 is 5. Negative 9 and negative 8 is a negative 17. So that's how you do scalar multiplication. Okay, the next thing we're going to do is matrix multiplication. This is a little bit more of an involved process. In order to multiply the matrices, the first thing you have to do is look at the dimensions of both the matrix that you're multiplying. And when you do that, the number of columns in the first matrix must be the same as the number of rows in the second matrix, and then your solution will be the number of rows in the first matrix times the number of columns in the second matrix. So, for example, a 2 by 3 matrix times a 3 by 4 matrix will have an answer that's a 2 by 4 matrix. So let's go ahead and take a look and see what that looks like. In this case, again, we have a 2 by 3. We have a 2 by 3 matrix, and here we have a 3 by 4, so that means my answer will be a 2 by 4. Now, multiplying is a little bit more complicated than adding. What you have to do is you have to multiply a row by a column and then add those together. So it's going to look something like this. In my very first spot here, because remember, my answer is going to be a 2 by 4 matrix. So I'm going to have blanks for each of the spots, and it'll look something like this to start with. Now, what goes into those blanks? Well, what I have to do is I have to multiply the first row by the first column and then add them together. So it'll look something like this. I have to do negative 4 times 5 is negative 20, plus 5 times negative 4 is a negative 20, plus negative 1 times negative 2 is a positive 2. That's my first row and first column, so my row 1 and my column 1, because I'm multiplying my row 1 and my column 1. Now, the next spot I'm going to do is multiply my row 1 by column 2. So I have negative 4 times negative 2 is negative 8, plus 5 times 2 is 10, plus negative 1 times 0 is 0. And that's going to be row 1, column 2. So the next one I'm going to do is row 1, column 3. So negative 4 times 1 is negative 4. 5 times 3 is plus 15. Plus negative 1 times 1 is negative 1. So that's going to be row 1, column 3. Now, row 1, column 4. I have negative 4 times 1 is negative 4. Negative 4 times negative 5 is a positive 20. Negative 1 times a negative 3 is a positive 3. So now I'm going to do the same thing for row 2. I'm going to do row 2, column 1, row 2, column 2, row 2, column 3, and row 2, column 4. So I have negative 2 times 5 is negative 10. Negative 4 times negative 4 is a positive 16. And negative 1 times negative 2 is a positive 2. So for row 2, column 2, negative 2 times 2 is going to be negative 4. Negative 4 times 2 is negative 8. And negative 1 times 0 is just 0. Next one, negative 2 times negative 1 is negative 2. Negative 4 times 3 is negative 12. Negative 1 times 1 is negative 1. And then we have negative 2 times 1 is negative 2. Negative 4 times negative 5 is plus 20. And we have negative 1 times negative 3 is a positive 3. Now, I just noticed a mistake that I made, and I'm going to fix that. This 5 times negative 5, that should be a negative 25. So I have to erase that and put in plus 25, and that will actually be a negative 25. So a negative 25 goes there. Now, to get my answer, what I have to do now is I have to go ahead and I have to do the addition. So I'm going to come up with my next matrix here, and I'm going to do negative 20 plus negative 20 plus 2 is 38. Negative 8 plus 10 plus 0 is 2. Negative 4 plus 15 plus negative 1 is 10. Negative 4 plus negative 25 plus 3 is going to give me a negative 26. Negative 10 plus 16 plus 2 is going to give me 8. Negative 4, negative 8 is negative 12. Negative 2, negative 12, and negative 1 is negative 15. And then we have 20 plus 3 minus 2 is 21. So my final answer is going to be a 2 by 4 matrix that looks like that. And now we're going to look at the same question, but what we're going to do is use our calculator to do the matrix multiplication. So the first thing we have to do is enter the matrices into our calculator. So I'm going to start off by hitting second, and then this x to negative 1 that has matrix above it, and then I'm going to go over and edit, and I'm going to edit the first matrix. The first thing I need to do is put in the correct dimensions. In this case, it's a 2 by 3 matrix, so I'm going to enter 2 by 3. Now when I go down here, I'm going to enter them in. Negative 4 and negative 2 are correct. Then I'm going to put in 5 and arrow down, negative 4, and then I'm going to arrow over here, negative 1, and then going to go to here, and that's negative 4. So now I have my matrix the way it looks. I'm going to go ahead and enter in the second matrix by just hitting second and matrix again, over to edit, but now I'm going to arrow down to B, and I'm going to enter in this matrix. This is a 3 by 4 matrix, so I'm just going to put in 3 by 4. And again, I need to put in the correct numbers, so that's negative 4, negative 2, and then we have 2 and 0, and then we have 1, 3, and 1, and then we have 1, negative 5, and negative 3. So now I've entered those all into my calculator, and again I need to go back to matrix. Now I'm just going to choose the matrix. So where it says names, I'm just going to hit enter, and whoops, I have to clear that. That's not what I want. Let me get rid of that. Get out of here. So I'm going to quit this. So what I need to do is clear this whole thing out. Now I'm going to go to matrix, and I'm just going to hit enter for number 1, and that gives me matrix A. So that's my first 2 by 3 matrix. I'm going to multiply that by hitting second and matrix and going down to B. So notice that it's a 2 by 3 matrix times a 3 by 4, which will give me a 2 by 4 as my answer. So I'm going to hit enter here, hit enter again, and that's my answer for my 2 by 4 matrix. And the last thing we're going to do is solve an equation. Well, to solve an equation using matrices, we start off by doing how we would solve any equation. So if I had the equation 2x plus a equals b, I would subtract a from both sides. So that gives me 2x equals b minus a. So the first thing I need to do is go ahead and do b minus a. Well, my b matrix is 2, negative 2, negative 4, and 6. Minus my A matrix, which is 6, negative 2, 0, and 2. Now, just like I did before, when I do negative, I'm going to add the opposite. So I'm going to make that negative, make that positive. 0 doesn't change, and make that negative. So now I need to add those together. So what I need to remember that I'm doing is I'm taking 2x equals b minus a, where this is b and this is a. So I have 2x equals 2 minus 6 is negative 4. And I have negative 2 plus 2, which is 0. Negative 4 plus 0 is negative 4. And 6 minus 2 is 4. So I have 2x equals that. Well, just how we solve any other equation, to get rid of that 2, I'm going to multiply both sides by 1/2. So I'm left with just x over here. Now it's a scalar multiplication problem. I just need to multiply each one of those numbers by 1/2. So negative 4 times 1/2 is negative 2. 0 times 1/2 is 0. Negative 4 times 1/2 is negative 2. And 4 times 1/2 is 2. And that is how you do solving an equation using matrices.